Hi there! Our preparation for the IB Mathematics Analysis and Approaches Standard Level exam starts now. Today we will study part 1 of the beginning phase, in which we will discuss Venn diagrams and basic probability ideas. As you will see, even in easy topics and non-challenging exercises, the objectivity and dynamism of the method will become evident. Would you mind taking 2 minutes to get some acquaintance with this 2018 Paper 2 official question before we discuss one possible solution thoroughly? There are 35 students in total, 5 of them in the remaining position. That is, 5 students study neither art nor music. First question: how many students take art classes? That is, how many students are members of Set A? 11 students take art classes only, while 6 additional students also take music classes. Now, we are told one student among the 35 students available is selected at random. In the first item, we do not want this student to be a member of Set A. Therefore, this student may study only music. Or perhaps this student is part of the remaining students, because he or she belongs to the complement of the union of the sets. The answer for this item is 18/35. As far as the last item is concerned, we are looking for the union of sets minus their intersection. In other words, we must add 11, the number of students who study only art, and 13, the number of students who study only music. And we must consider the sum over the total number of students, each one of them equally probable to be chosen. The official mark scheme will always appear right after our solutions, so that you will have the opportunity to check the examiner's ideas afterward. We know Venn diagrams are helpful when dealing with probabilities right from the start, as this new exercise suggests. Would you please get some familiarity with this 2019 Paper 1 official question before we start our discussion? The probability of event A is 30%. Based on the fact that 10% is for event A only, 20% is associated with P, the probability of the simultaneous events A and B. To find the value of Q, the probability of event B only, you must realize the certain event has a probability of 100%. Hence, set U is associated with 1. The set A or B has a probability of 60%. Therefore, point 1, point 2, and Q must add up to point 6. If you prefer, the probability of A plus Q must be equal to point 6. Q is equal to point 3 using any one of those two paths. Finally, we look for the event B union the complement of A. That is, the probability of event B plus the probability of the event neither A nor B. The answer follows from the diagram. Think about this 2018 Paper 2 official question for the next 2 minutes, please. Let's use the Venn diagram, as in the previous exercise. Be sure you understand the red numbers and the fact that we are looking for the value of the probability of event A and not B. The answer is simply 0.62 minus 0.18, of course. For the second item, note that the complement of the union of events A or B is the intersection of the complement of each of those sets. That's why point 19 is correctly placed in the remaining part of the Venn diagram. The examiner asks for a conditional probability, A given the complement of B. By definition, we must obtain the probability of event A and not B over the chance of the event not B. The numbers needed were given or already calculated. Please use your GDC to find the final numerical value. Just a small detail. In the following lessons, we will discuss how to use the Casio FX CG50 calculator efficiently. You need this skill for a high grade in your IB exam. Let's go a bit further in probabilities. Check this problem from this 2017 paper 1 official question for the next couple of minutes. Five green balls and 3 white balls are in a bag. We will take one ball out at random, followed by another one without replacing the first one before the second extraction. Be sure you understand the numerical fractions related to the first extraction. There is a 5/8 probability of selecting the color green for the first ball, and the complement of that for selecting one white ball at the first extraction. What about the branch related to the 4/7 probability? After the first green ball extraction, the bag has 4 green and 3 white balls. Therefore, there are 7 equally probable balls for the second extraction, 4 of them favorable. The complement is associated with a white-colored second extraction, considering the first extraction was a green ball. On the other hand, if we take out a white ball at the first extraction, there were 7 balls left in the bag, 2 of them white and 5 green. The blue fraction is easy to understand using the same previous reasoning. You may find the yellow fraction by complementarity, or if you prefer, just thinking about the number of green and white balls before the second extraction, once the first ball extracted was known to be white. We have 2 scenarios to have precisely one of the selected balls green. Extracting one first green ball, followed by one white ball, or vice versa. The sequential 2 balls extraction, shown in purple, has a probability of 15/56. The other sequential favorable 2 balls extraction also has the same probability. Check that. Because these two sequential two balls extraction events are mutually exclusive, that is, they cannot occur simultaneously, the probability of their union is the sum of their probabilities. We will finish this first lesson with another probability question. This problem is the previous to the last exercise of a 2018 Paper 1 exam. Have a good look at it for the next 2 minutes, please. There are n marbles in a bag. Precisely 2 of them are blue. Let's say the others are red to simplify our wording. In the first extraction, what is the probability of getting a blue marble so that the game ends? 2 favorable possibilities among n equally probable ones, for sure. What about a first red marble followed by a blue marble in the second extraction, no replacements involved? We have 2 less than n red marbles to choose one among the first n equally probable marbles. After the first red extraction, there are still 2 blue marbles in the bag, but among 1 less than n equally likely possible marbles. Now the examiners tell us to use n equal to 5. Hence, calculating the red, blue sequential extractions is done with the same reasoning, but with numerical values. The fourth draw ending game is done with the same rationale. Finally, to have a fair game, we must have an expected value of $20 for the money earned back, according to the number of draws and the probability of ending the game at that precise number. We use the probabilities calculated in the previous items, and the equation created is self-explained. If you have any doubts about this problem or the ones that came previously, please feel free to ask below in the YouTube comments or inside our study platform presented at our website www.gmath.net. Kind regards, and I hope to see you in our next lessons.